Alright, so yesterday we did composition of functions where we evaluated the function. So x had a value, so we put in 2 or whatever, 3. Today is going to challenge you more. I'm going to go ahead and put that out there. It's just a whole lot more of algebra stuff that you have to do. So we are going to find these compositions where x is x. Doesn't have a value, the value changes. So our answers aren't just going to be like 0 or 3. Our answers are going to be expressions. And so it's going to be fine. It'll be okay. And we're also going to tell the domain of each of our compositions. So one thing to remember about the domain is you cannot just look at the final answer. You have to look at all of your work that you did for the whole problem to figure out the domain. All right, so let's just get started. So on example 4 and 5, we're going to find f of g of x and g of f of x, and we're going to find the domain of each of those. So let's start with f of g of x. I'm going to color code this. Maybe that'll make it a little bit easier. Oh, I don't have a green highlighter yet. Okay, so we're going to do f of, and then I'm going to go ahead and just write what g of x is in the parentheses. So g of x is x squared minus 3. Alright, so that means I'm going to take x squared minus 3, and we're in f, I'm going to put it in the place of x. Alright, so we're still going to have the square root. But instead of under the square root having x plus 4, we're going to have x squared minus 3 plus 4. So just x becomes something new. Everything else stayed the same. Okay, so at this point, this is f of g of x. We are going to just simplify what we can. There's not a lot we can do. Really the only thing we can do is combine your like terms underneath the square root. And that should be your final answer for f of g of x. Alright, let's look at the domain. So we do have this even root. So it would seem like you would need to simplify the domain. So what's underneath that root has to be greater than or equal to 0. So is there any number that you can square and add 1 to and ever get a negative under that root? Nope, because every time you square a number, positive or negative, you get a positive. A positive plus 1 is always going to be positive. So the domain, even though there is a square root, the domain is all real numbers. So that's a little bit tricky. Okay, now we have to do it the other way also. Now when you guys go to do your assignment, I don't have it up here, it's probably not going to ask you to do it both ways every time. So just make sure you follow the directions and don't do more than you have to do. I mean, it would be good practice, but it will take a long time. All right, so on this one, we're going to do g of f of x. Or g of f of x is this whole thing, so g of the square root of x plus 4. Alright, so what that means is we're going to take that square root of x plus 4 and we're going to put it in the place of x. So that means we're going to square it. And then we're going to subtract 3 from it, because that's what G does. It squares things and then subtracts 3 from it. Alright, so when you square that square root, what happens? Exactly, the square root goes away. So G of f of x is just going to be x plus 1. Now, when you look at the final answer, it looks like the domain is going to be all real numbers, but it isn't. You have to look at all the stuff throughout the whole problem. So if there was ever an even root, what's under that root cannot be negative. And so because I have this even root right here, if I started at this point in the problem and I put in -5, then it wouldn't work. It wouldn't function. So we would take what's under that even root and say it's greater than or equal to 0, and then say solve it for x is greater than or equal to -4. That's your domain. What happens inside all your work matters for domain. It's really hard to get those questions right because it's tempting just to look at the final answer. Okay, we're going to do one more and then we're going to do an application problem. All right, this one is kind of a weird, 2 weird functions. Oh, I do have it over here. Yeah, it looks like on your assignment it just asks you to do it one way. You don't have to do two different compositions for each problem. All right, so we're still going to practice it both ways here. So we're going to have f of x and g of x. And the first thing we're going to do is f of g of x. Or f of, and then I'm going to write what g of x equals in the parentheses, 7 over x plus 6. Okay, and this is a weird problem, but we're going to take what that is, and we're going to put it in for x in f. Alright, so on f, we have a 1 in the numerator that we do absolutely nothing with. Alright, and then instead of writing x here, we're going to write 7 over x plus 6. And then we still have that minus 6. This minus 6 has to be here. Alright, so what would you guys do first if you were doing this on your own? What would happen with those 6's? They would just subtract away, and this would be 1 over 7 over x. Alright, now we cannot leave our answer like that. So do you guys know, remember what to do if you're dividing? Like this is 1 divided by this denominator. How do you divide by a fraction? Very good. So this is the same as 1 times the reciprocal of that, which is x over 7. So g of f of x is x over 7. So when we find the domain, like I have been saying, we cannot just look at that final answer because that one would have all real numbers. We have to look at the whole problem. And so here and here, if x was 0, you would have 0 in the denominator, and we can't have that. So x cannot equal 0 is your domain. Okay. All right, and then let's do it the other way. G of f of x. All right, so it's going to be g of 1 over x minus 6. All right, so we're going to go to g, and in the place of x, we're going to put this whole thing. So we'll still have 7 in the numerator, but our denominator is going to be 1 over x minus 6. All right, and then we're still going to have that plus 6 from g. I know, this is a lot. There's a lot of algebra. There's lots of so many tiny little places for you to make a mistake. Okay, so we're going to have the same situation we had right here. So we have, here we had 1 divided by something. Here we have 7 divided by something. But we're going to do the same thing. We're going to take 7 and we're going to multiply it by the reciprocal. Now, you never have to write over 1 if you don't want to. If that confuses you, just leave it off. It's fine. But we just flip that over, so that left with 1 in the denominator. So I distributed that 7. And then the last thing I need to do is just go ahead and combine my like terms. 42 minus 6, which is going to be, sorry, negative 42 plus 6 is going to be negative 36. Alright, now we're going to do the domain, but we are not just going to look at the final answer. We're going to look at all the work. And right here, I have an x in the denominator. So this denominator cannot be 0. So what can x not be? What would we put in for x right here that would make that denominator 0? 6. So x cannot equal 6. Alright, so take that in for a second. I actually surprised I didn't mess something up real bad, or maybe I did and I didn't notice. Do you guys have any questions? Okay, this last one is kind of a doozy. And it's kind of gross. Like, it's going to make sure you keep your food in the refrigerator. So, the number N of bacteria in a refrigerated food is given by this function, where it's N of capital T, where capital T is between 2 and 12, and it is the temperature of the food in degrees Celsius. All right, when a food is removed from refrigeration, the temperature is given by this other formula, that T is the temperature in Celsius, and then lowercase t is the time in hours that the food has been out of the refrigerator. All right, and so what we're asked to do, whoa, I don't know what just happened, is to find N of T of T, N of capital T of capital T. So that little notation it's not super common, but I don't like it. So I will always rewrite it as N of T, like that. So what that means is I'm going to take what capital T of lowercase t is, which is 2t plus 2, and I'm going to put it in. I'm going to put it into the N function for both of those capital T's. Alright, so that means I am going to multiply by 8, and then what I'm plugging in for T, I'm going to square it. Then I'm going to do 14 or minus 14 times whatever I'm plugging in for T, and then plus 200. Alright, I'm going to move over a little bit because this is going to take up some space. Okay, can I distribute this 8 into those parentheses? What do y'all think? Right here, can I do that? You can't because it is squared. So if there's a power on your parentheses, they're locked in. You can't distribute inside them because of that power. So that 8 is going to just have to hang out for a second. All right, what does it mean to square something? You're going to multiply it by itself, absolutely. All right, so that's going to take a minute. All right, I can go ahead and distribute this 14, or negative 14, because there's no power on my parentheses. All right, and 200 can just drop down. I need to change colors. All right, and now you have options. If you wanted to distribute the 8, you would just do it to one of these. But I am still going to let this 8 hang out. And I'm going to distribute to T. And then I'm going to distribute 2. And you might be able to do this faster than I'm doing it, and that's great. Some of your algebra skills are stronger than others, and that's okay. All right, I am going to go ahead and just combine that negative 28 and 200 and get it over with. And to save on time and space, we all know that those are going to add to equal 8t. So when I distribute it, I'm just going to go ahead and make that an 8t. And I'm going to rewrite this as n of lowercase t. It's fine. Okay, so we'll distribute that 8. And then finally, I'll combine all my like terms. All right, and that's my new function. And then for B, we don't really have to do anything. We just need to interpret. We don't have to do anything algebraically. We just have to interpret what this means. So what does this new function tell you? So what was capital N in the beginning? Is the number of bacteria. So this is still number of bacteria. Now the original N was the number of bacteria based on the temperature of the food, but that was when it was capital T. Now this is lowercase t. What does lowercase t represent here? Time. So this is the number of bacteria given the time out of the refrigerator. So let's say you left something sitting on your counter for like 3 hours, and then you decide you want to eat it. So I'm just putting 3 in for T. Oh, it's just 600 bacteria. That's not too bad. Oh, it's still gross. So keep your food, put it away. All right, any questions? All right, so yesterday I gave you the packet. There's only 5 questions on it that we're doing there. It'll take you plenty of time. So on that packet, I just want you to do 22 23, 25, 32, and 37. And follow the directions, so don't do more than you have to do.